Hello and welcome to 21st lecture of course on corrosion, environmental degradation and surface engineering. Topic of this lecture is a selection of non-destructive techniques. Now, even though we are mentioning the NDT or non-destructive technique, but this selection procedure what I am going to describe in this lecture will be applicable for many other things. Like if I want to select the material coating, I want to select any tribometer testing, that also will be same, procedure will be same. However, just to highlight this complete procedure, I am choosing NDT because recently we have completed in a previous 3-4 lectures, we have completed these techniques. We covered 9 techniques, one visual inspection, second ultrasonic, third radiography, fourth magnetic, fifth eddy current testing, thermographic testing, liquid penetration testing, acoustic emission and stress strain DIC testing. I mentioned also the stress strain DIC testing is a more like a recent one, and then there will be continuously there is a possibility of continuous improvement in this kind of testing. In addition, I have picked up this slide from my earlier lecture. We say there are total 6 classification or 6 classes of the crack. We say this is the linear crack which will try to break the surface, and this will be treated as a volumetric crack to break the surface. Now, this the initial first crack and third crack is almost same, but this crack is not on a surface. So, that is why we use a word the near surface linear normal to the surface crack. Now, if I make a orientation by 90 degree, then the fourth class comes, which is also the near surface, below the surface, it is not on the surface. In the similar way, we can have volumetric cracks also. One is a near surface, another one is slightly on the depth side. That is why we use the word the subsurface volumetric crack. Now, just to detect this 6 type of the cracks, we can use a number of NDT's techniques. We say that we can use a visual technique, we can use a liquid penetration technique, we can use a magnetic particle, ultrasonic, radiography, eddy current, thermographic, acoustic emission, and of course, the 9th one also we can use a stress strain DIC testing. Now, we have given the numbers in this table. Let us take an example. Here is a 0 number. 0 means this technique cannot be utilized at all. Like visual technique, we cannot see any crack which is not on a surface, it is just below the surface or the subsurface. So, this and then we are giving a 0 number, that this technique is unsuitable for the this 4 type of the cracks. Same thing for the liquid penetration also, that is a basically surface detection technique, it cannot be used. If I try to cover the even the 9 number stress strain DIC testing, that is also applicable only for the surface. So, if I go with the 9th number technique also, this technique will get a 0 number. Now, coming to the 3 number, in this case we are giving highest number as a 3. That means, this 3 number variable reason that this technique is very good to detect this kind of crack. Now, then the surface breaking linear curve, because the size is much smaller, quite possible in visual technique may not be sufficient to utilize. So, that is why we require some sort of addition or maybe some additional equipment for that. So, that is why we are giving here the 1 number, and the highest is a 3, as I say worst is a 0. 1 will be that maybe it can be utilized, but we really require some more careful inspection. Coming to the 2, it will be somewhere better than 1, and then but it is not as excellent as a 3. So, these are the techniques which we give numbers to the various techniques, so that we can quantify selection procedure. We can talk lot, we can go ahead with the subjective selection, we can go ahead with the cost simple one selection, whichever the cheapest available, cost economic available, or whichever is available are having a highest accuracy, I can select one. But when the parameters are 3, 4, then selection will turn out to be little more involved. Again, we are giving these numbers based on some understanding, and as per my knowledge, every day there is some change in a technique. Maybe magnetic particle in the testing get enhanced, or maybe the accuracy is improving, or maybe the acoustic emission addition mechanism, the way the sensor should be attached is improving. So, that will take much lesser time to record the data, or maybe database is continuously increasing. So, today whatever the number 2 it is getting in the surface breaking volumetric testing, quite possible tomorrow it will get a number 3. So, these are the tentative numbers, and the number has been given for the just explanation that how this selection procedure should be utilized. So, again I can say whatever the numbers has been mentioned, these are the relative based on the understanding, and now if one place thermographic images are not coming good, or maybe the camera is not very good and excellent, then quite possible that will not get that good number. And if it is somewhere eddy current is being performing very well, it will get all three number, but coming to the non-conductive material, it will get a 0 because eddy current cannot be utilized for that. Coming to the magnetic material, magnetic particle, if this material is not a ferromagnetic, naturally it will get a 0 number, it will not be useful. So, these are the kind of based on understanding. For that purpose I have kept 3 slides just to summarize. Now, visual inspection which we started, and then we say that it is a direct examination of object, and then we can find out really cracks, corrosion, abnormalities, and there are a lot of video movies also available on in a number of channels, and I am referring to one of the video movie in this. It is basically we can really run the movie, we can see it, and then as I mentioned that there are more and more research really happening in these areas. So, whatever the lecture I am covering, quite possible after 6 months there may be somewhat change will occur. So, number may change. So, I request if you want to utilize this method for practical purpose, for industry purpose, please keep looking at the current research which happened, or maybe the available technique which have been improved compared to the previous techniques. Now, in this case, as I earlier mentioned that visual examination, we even to try to look at with the naked eyes, but we can really zoom it, we can really go ahead with optical microscope, it can be added in that purpose. And another thing is that when we go for the testing, naturally that how the refinement is really happening to the process also. You look at that the very bad weld joint has been shown in this and then the connection, or maybe this joint, but quite possible we go better and better in the improvement in the welding joint itself. So, even the visual technique which can be utilized for present purpose or for current purpose, quite possible if there is a good manufacturing happening, visual technique may not be useful. So, again we really need to look at the current research or current data or current technique and how the equipment have getting improved, and based on that we should go ahead with the selection procedure. What procedure I am trying to explain in the present lecture will be applicable even for the future, for the after 10 years or 15 years. Technique number, with the number which we have been providing, that may change to some extreme. Other testing we use, that was ultrasonic, we say that is a high frequency, that means a low wavelength, that means it can really go inside and find out the very fine the flaws also. So, that is why that is very good for the finding the flaws and even finding the material thickness, or over the time how the thickness is changing, that can be done, that can be utilized. So, again I am showing the one of the video link over here. These are the common techniques available on the website on the number of channels, and then we keep looking at those and then how the things are improving, and then we can give our own numbers to the this technique. Radiography, which is a slightly expensive technique, and then it really requires a high energy like X-ray or gamma rays, and then they try to really visualize a complete say flaw or defect within a complete body of the this maybe in this case we are showing a tube inside how the really flaws are happening and what kind of welding has happened. We are able to look at the 3D image kind of the flaw, the 3D image of the flaw inside the object. So, this is very good, but again as I mentioned it may be the costlier one and may not be easy to really mount and immediately utilize for the in situ purpose. So, maybe may not be suitable. So, it depends on the what is really our requirement and what is the object. So, the technique importance will change based on that. However, we really require good understanding of the technique, good understanding of the method which we are going to utilize. Again, we have given here the link where the movies can be seen, and then look at what kind of improvement have happened in the recent past. Same thing we are also showing the magnetic particle testing, and we say that it is not only the surface. You look at this surface, even the near surface, there is if there is some sort of the depth in that there is a crack, then we will also be able to figure out what is a really problem. So, the magnetic particle is not only suitable for the surface, but to subsurface also it can be really utilized to the betterment also, maybe to the better extent. So, this is only the constraint is a ferromagnetic material. If the material is a ferromagnetic, then this MPL can be utilized, otherwise it will not be utilized for a non-ferromagnetic material. Eddy current, which is one of the very cost effective technique in these days, and that has been utilized for the years and years. That is why the technology which has been developed in this field is really very good, and then particularly noise cancellation and kind of the sensors which are available for this kind of testing are enormous, maybe even the cost effective. So, many people try to utilize the eddy current testing procedure, and then it says is not only it also detect the surface and the near surface defects. Now, only the problem is in this case the conductivity, that if the material is not conductive, then it will not be utilized or will not be able to utilize effectively. So, these are the some constraints. If the material is non-conductive, we cannot utilize the eddy current. If the magnetic particle, the ferromagnetic materials is not, the object is not made of the ferromagnetic material, we cannot use the magnetic particle testing. We mentioned also the thermographic is a very cost economic. It gives a whole surface in one go, and then we can really get a kind of error which kind of problems there, but going with a fine detail really we require a lot of filtration, lot of post processing. If we have those kind of softwares available or good cameras, we can go ahead with thermographic images or thermographic testing. However, we want only glimpse what kind of faults and where the fault is located. Okay, that also possible. In this case, we are showing here the gear has a lot of flaws, and we are able to show the thermographic image. As I mentioned, every surface emits emission, and then gives a thermal emission, and based on the crack, or maybe if there is a crack or some sort of discontinuity, there will be disruption in heat pattern, or maybe thermal pattern or temperature pattern that need to be recognized and utilized. So, again if there is a more and more research is happening in this area, naturally we will be getting better and better equipment, and then we can choose those kind of equipments. We also this is one of the cheapest one, liquid penetration test. It has been utilized for the the various sources. We are able to see here that the big patch of liquid dye that indicates that there is some more flaw at this place, and again it has been utilized only for the surfaces, and the below surface or near surface that cannot be utilized, and then this one, and that is why the crack and the surface the porosity and localized defects can be utilized for in this kind of test. Now, acoustic emission, which in the previous lecture we covered, stress strain DIC in previous lecture we have covered in detail. We also mentioned that acoustic emission, that the way thermal emission occurs, acoustic emission also occurs from different materials and different processes, and whether the crack is getting initiated, crack is getting propagated, or maybe the coating is getting damaged, getting cracked, or maybe the delamination is happening, and acoustic emission will give a kind of a report, or maybe the signals, or we need to really capture and do good post processing. If the post processing tools are available, then we can go ahead with acoustic emission test also. However, many times installing the sensors will be a kind of a problem. Particularly, we covered in previous lecture that we use a sensor on a rotating element, that will be far preferable. It will have a high signal to noise ratio compared to the when we are attaching to the unit which is stationary and a bit far away from the location of errors or flaws. Coming to the strain DIC, as I mentioned, it is a recent technique, Again, it is mostly used for the surfaces and then which are not so easily accessible, and we try to capture many images, and then we try to then compare the pattern, and it can be the same finite element method the kind of technique can be utilized for this kind of testing, and it will be really giving a good result, but again only related to surface. Subsurface, it will not be able to give a good results. Now, we have covered this technique. Again, this 9 technique are not a complete technique, as I am able to figure out from my literature. Many new technique keep coming, maybe like if you find some papers which are review papers, they have explained almost 50 non-destructive testing. So, we do not want to go more in detail about the non-destructive testing, more or less purpose we know, and then now we are coming to the how do we select good NDT for our purpose. So, that is why we say NDT selection using, now we are using the word weighted objective method. Weighted objective method is one of the method like optimization method, but in literature there are number of optimization method, those can be utilized. For this course we are trying to utilize only weighted objective method, and what is this method we will be explaining in next 3-4 slides. What we are seeing that which method will be the best for you, the NDT method that can find and analyze the defect. So, finding is not only sufficient, analyzing and kind of the defect, and if it is possible to classify the defect, that is a defect or flaws. Now, it is if it is really satisfying all of the quality standards, if it is really matching, and maybe say there are 30 flaws and we are able to find the 30 flaws, that makes a lot of sense to us. If there are 30 flaws and we are able to figure out only 15, naturally whatever the innovation capacity or whatever we are trying to improve the system, it will not get improved that much, because we are not getting all kind of faults, or maybe we are getting only bigger faults, not a smaller one. So, we are not really reaching to the root cause failures, but we are able to figure out maybe after some damage has already happened. So, in that situation, if more and more, or maybe say almost all the flaws, if we are able to capture, that method will turn out to be the best, and we try to utilize this optimization method for that purpose. That is why we are saying the NDT method that can find and analyze the defect or flaws satisfying specified quality standard whatever we are trying to set, and requirement, that method should be chosen or selected. Now, sometimes people use a word like efficiency, I want efficient method, or efficiency of the method should be very high, then there is a need to really mention what is the meaning of that. So, I am just trying to show the examples, like sometimes people say efficiency means how quickly NDT method can identify and evaluate flaw or defect. How quickly we are able to diagnose a flaw which is really happening inside the surface or the surface. Sometimes you say, people say that the efficient method means it reduces inspection time, the inspection time is lesser and output is very high. That means it is really giving a good output, maybe say almost all the kind of faults, then people say that it is the efficient method. Sometimes we worry about the cost, and often the mistake is happen, people talk about only the equipment cost, but what will be the staff cost, because here the time which is taken, it is also related to the staff cost, and then whether really without training that equipment can be operated, or really we require extensive training to operate that machine. That means if the concerned person is not there, that machine cannot be operated. So, the staff, the kind of the requirement of training and kind of involvement of the staff is required, that also matters. And last one is that quite possible that the testing equipment is there, training person is also there, but this requires a very frequent maintenance or requires a minimum maintenance. Those things are important when we are trying to select this testing method. And one more thing is that what kind of precision, what kind of reliability we are going to get out of the results, that also need to be considered. Now, what are the steps in weighted objective method, that is a WO weighted objective method, we say that what are the relevant parameters for our purpose for the NDT selection. Now, what are the relevant parameters? It can be efficiency, it can be quality assurance level, it can be difficulty level, that we want a simplest equipment, we do not want a very the difficult equipment, or maybe the economic criteria, or maybe the safety, then whenever the person is operating, he should be safe, like there is a problem related to gamma rays, and many people do not want to get exposure to the gamma rays, even X-rays also. So, the safety will come into mind, and then another one is time, how fast, how quickly we want that. So, these are the some parameters which need to be selected before starting the selection procedure, or maybe say when we want to select the entity method in this case. However, the same procedure can be, or maybe similar kind of parameter will come when we go for the coating selection, or we go for the tribometer testing, and then the selection of the tribometer meters, which are really available in many we say the numbers. Simulate tribometer can be utilized for general number of purposes, or maybe specialized tribometer can be utilized. So, those things will be also important for us. Now, what we are trying to do in this method, we are trying to assign numerical weights. I have seen the many optimization method, they say that everything is the same weight. That means efficiency, importance, quality assurance importance, safety importance, time importance, everything is almost same. We are not giving special weightage to anything. In other scenario, we can say no, safety is number 1 important, efficiency is number 2 important, and then quality assurance is number 3 important. So, we are ranking. That is what we need to quantify, and in this course, in this lecture, we are saying that assign numerical weights to each parameter whichever selected. So, that is what I mentioned. Whether we want to give more importance to efficiency, or we want to give more importance to quality assurance. The selection method will be slightly different than the method which will be selected will be maybe the different also. So, these things need to be evaluated properly. Another one is that every entity technique will have a merits and demerits. Can we quantify that? Yes, we can quantify. That is why we use a word utility score to quantify the technique. So, that is why we will explain through the one example. Then finally comes what is the overall score. Maybe we can give a ranking based on the 10 points, we can give a ranking on the 5 points, we can give a ranking on 100 points. I will be selecting the 10 point based ranking, that out of 10 what is the score of each technique which we are trying to select, and then highest score may be selected. If you want highest value, or if you want the minimum value, the lowest value should be selected, which this will be explained in this lecture. And then we will be, based on that, we will be overall finding the score, and then we will be selecting suitable non-destructive testing. As I mentioned, there is a possibility that this technique can be utilized for the number of this method can be utilized for number of other purposes, the coating selection, or maybe the destructive testing selection, or maybe surface engineering approach selection, whichever method. But if this method, weighted object method, is clear to you, that can be utilized. Now, what are the assumptions? Assumption, as I mentioned, that different aspects like efficiency, degree of difficulty, cost may have varying importance. That means, there is assumption that these are having a different kind of importance, they are not the same. That means, I will not treat the time and hardness in the same value. That maybe we do need to do a lot of normalization, so that we can really come up with a right number. As I mentioned, that we will be doing a normalization in a manner the overall ranking comes in a number the 10 value 0 to 10, 0 may be the worst and the 10 may be the best, and then we will try to frame this complete method based on that. So, what we can say, weighted objective method offers a framework for comparing alternative non-destructive testing, and then the method will assign numerical weights to different parameters and finally quantify. So, we will try to minimize subjectivity, and we will go on objectivity side. We will try to give some number, so the results are better and better to us. Now, we will just take one example, one case study, that is what we say welded joint, and which technique will be very good to figure out kind of faults which happen in a welded joints. And as per my knowledge, most of the time when the staff, or maybe say the operator do this welding, manual welding, the many flaws will come. and I already covered like in the bridge which have been fabricated in situ, and then the welding happens over during the manufacturing at the site, and most of the time these welded joints are we say that having a number of flaws. So, the beginning itself the bridge has a flaw, naturally after 5 years 6 years the flaw will increase significantly, and there is a possibility of the bridge collapse. So, that is why the maintenance of the bridge will increase significantly if these joints are not manufactured or maybe say made properly. So, we are trying to cover that kind of example, and then I am just not going for the bridge failure, we will just focusing only the welded joints on what kind of flaws and how to diagnose those flaws. Now, what are the really the parameter which should be selected? As I mentioned, there is a possibility that we can select the efficiency, we can select the quality assurance, degree of difficulty, economic criteria, safety and time, and then this need to be really having numbers. So, some maybe initially we have some testing done in our lab, then we can have a number, how I will be picking up these numbers from a literature. Now, what are the different entity which have been widely used for this purpose? And literature indicates that mostly the 5 techniques have been utilized extensively for this purpose: ultrasonic testing, magnetic particle inspection testing, acoustic emission, radiography and eddy current testing. These are the 5 techniques have been utilized for the diagnosis in the welded junction. And now, what are the different kind of flaws in a welding junction? We say that poor weld quality due to the presence of inclusion and slag, which happens almost in all the welding which is done manually. And then there will be a possibility of crack, because we do a melting and then solidification in situ, and there is a possibility that some crack remains here or some sort of a pores remains here, some gas bubble gets trapped here, or maybe that there is no sufficient flow because the temperature we are not able to control, somewhere there is a more cooling, somewhere more heating, that quite possible that there is some sort of cavity remains during the filling the gap. And there is another one, there is a possibility that we started and it does not reach to the depth, that means there is an incomplete penetration, and then the reason being that there is a solidification before it really reaches to the desired location. So, there is a lack of the fusion or incomplete penetration. I have shown couple of the figures here. We can see here the incomplete penetration. You are able to see the liquid has not reached to this location, liquid has not reached to this location, and liquid has not been reached to this location. So, we say the lack of side wall fusion, and then this inter-run fusion, maybe there is the surface, and then again the next one which is having some sort of a trap or some sort of a gap. So, that is why there is it's not insufficient. So, it is we can say incomplete penetration. There is a possibility there is some inclusion keep coming with maybe because of the dirt, because of oil, maybe because of some other sources. So, the inclusions are possible which is coming along with the weld junction. We know that because of the inclusions there is a possibility of the crack and that it will grow, and there is a possibility of the corrosion or maybe the crevices corrosion which happens. So, that will maybe initial. So, that is why we say inclusions or is another possibility. Now, you are able to see here the gas bubbles, small gas particles. It can happen a subsurface, it can happen also on a surface during the solidification. So, porosity is another possibility of defect, and it really happens. One of the worst thing is kind of a delamination. Now, here the weld junction is coming from a top, and then there is a separation of the surface itself. So, this kind of the delamination happens. Now, apart from this, there is a possibility of the transverse crack which is perpendicular to the weld direction, and there is a perpendicular along the weld direction, that is a longitudinal crack. Now, this crack can be surface and can be also penetrate into the inside. So, in this case it can be visible, visual inspection can be done also for this. However, we want to stick to this 5 method which have been extensively used to detect the welding flaws. So, what I say what kind of different flaws I am trying to reframe that. We say that whenever molten metal cools unevenly, it is not, if it is even cooling then there will not be problem, but mostly and the uneven cooling creates a problem. Reason being, even the liquid get trapped in the weld itself. So, some where the solidification happens and some where the particle only this liquid remains trapped inside. This is one possibility, and sometimes that is why we call as a slag or inclusions. And what will happen result of that? It will weaken the area, and then it will really compromise the structural integrity. So, wherever the flaw comes, it is going to compromise the structural integrity. And another one, to evaluate, naturally we will require a non-destructive testing. That is why we are giving a lot of importance for to figure out, is there any slag, is there any existence of the slag. So, that if they are, then we can remove, we can the defect, or maybe in future we can fine tune our welding procedure to minimize the slag formation. And as I am mentioning here, that most of the failures which I have seen, if they are automated, most of the things can be tuned very well because of the knowledge. However, the manual, it is a subjective. That is why I at least say that most of the defect in welding occurs because of the improper procedure which has been followed. Sometime we find and the unfortunate thing is that because of the high temperature, even the operator who is operating, he will not be able to really figure out how much porosity is getting created there, or is there any lack of fusion, or maybe there is an undercutting. These are the mistake remains because of the high temperature, and we say that it is not a comfortable environment as such for an operator. So, I prefer to go ahead with more and more automation of the welding, but as I understand it is a bit difficult, bit costlier. That is why the many times the manual welding is done. And then because of this lack of following the complete procedure, there will be like insufficient joint preparation. Sometimes edges are not made properly, or sometimes the electrode is not located properly. These are the problems will keep coming, and on the top of that, if there is a corrosion environment and there is an erosion environment because of the atmosphere, then what will happen? Even the minute defect which remains during welding procedure will become a very big as such because of the corrosion and erosion phenomena which happen in environment. And then if we are able to evaluate NDT using the NDT method, we can really repair fast, or maybe we say that we can upkeep the part easily. However, there is another possibility that during welding there is some sort of foreign material, maybe when the dirt particle is coming, or maybe say that the oil is also there, it is not getting clean, or maybe because of a high temperature there is a formation of the oxide or sulphide because of the environment, that will become an inclusion into the surface, that also will cause another problem. And as I figure I showed, the lack of fusion is maybe cause a major problem as a incomplete penetration. So, whatever the weld junction we want to make, we are not able to make it because of the incomplete penetration, and it becomes a serious weld problem. And then we say that that is not reaching, it is possible that it is not really that there is a separation or possibility of delamination, or even the possibility of the cracks at a number of places. Another one, because we sometimes use gases, and then the gases environment, the gas bubble also get entrapped into that, causes the porosity, and maybe say the blowholes, so that is one. And then sometimes the blowholes becomes in a chain form. So, that is becomes like an air tube kind of fault. That is also one possible. And then another possibility, as I mentioned, that particularly wherever it is getting attached to the other surfaces or two different surfaces, then they crack at any one place. Naturally, initially the crack will be there, then it will continuously propagate. So, it is will cause a more problem. Now, if the crack itself is like a crater crack, which is a bigger in a size, like a volumetric crack, then the more and more problems will be there. So, that is why whatever the weld junction is manufactured, NDT is a must to get. We should be utilizing NDT for that purpose. Now, let us start with our method, the welded objective method. In this case, I have taken as I mentioned that 5 techniques. Ultrasonic is a number 1 in this case, magnetic, acoustic number 3, radiography 4, and eddy current 5. This does not mean that number 1 means ultrasonic is the best. I just looking at only sequence. So, I am not using the word the best or worst in this phase. However, as I mentioned that we need to pick up the data, either we perform experiments in our lab and get a data, or we get a data from literature. Sometimes the data are not available in literature, we get some sort of curves, we can digitize those curves. So, in my next lecture I will be explaining how to digitize the existing curves and how to interpret the results. So, in this case what we have done, efficiency ratio that has been picked up from one literature, that they mention efficiency ratio as a 1.4 for ultrasonic testing, magnetic particle testing efficiency ratio is a 1.99, acoustic emission is a slightly lesser this ratio is a 0.88, radiography test 0.99, eddy current is 1.37. So, these are the picked up data from literature. Next one is the degree of difficulty, how difficult is one method to be utilized, that ultrasonic gets a 3.11, magnetic particle gets a 2.08, acoustic emission 4.07, radiography 4.31 and this 2.68. Now, here if you see, we want this efficiency ratio to be increased, this ratio needs to be increased for the better results. However, degree of difficulty needs to be reduced. So, this is a reverse order. Here we want more and more and higher value, and this one we want a lower and lower value. So, if I look at only absolute value only based on efficiency ratio, I will say 1.99, the magnetic particle testing method is the best. Now, coming to the even degree of difficulty, lowest they need to be minimum. So, then again the magnetic particle testing will be the best in this situation. Now, coming to the cost per feet, whatever the material cost which is being given and picked up from this website, they give a per feet cost is something like ultrasonic testing, their number has been given as a 3338, coming to the magnetic particle 3568, acoustic emission around 10,000, and then radiography 3730, coming to eddy current 2000. So, in this case, if from a cost point of view, I will say the eddy current testing is the best, because again the cost needs to be minimum. Coming to the time, of course, they have not included in the setup time. If you include that, it will give more better picture. For time being, to explain this method, we have picked up the data and we find again the magnetic particle which takes a minimum time to really set up everything. So, it takes only the 2 minutes, and then the next one is ultrasonic testing takes 3 minutes, and the eddy current takes 3 minutes, while acoustic emission takes a very high time of 20 minutes. Again, this may change, maybe better and better acoustic emission method have evolved, which have easy to mount sensors, which do not really require a lot of time to mount the sensor, it is simply sticking, it is a possibility. So, in that situation this time may come down to 3 minutes, maybe come down to the even 1 minute, depends. So, that is why we say that we keep continuously looking at what is the really advancement in this kind of technique. So, in this case at least the 3 parameters have been selected, the efficiency ratio, magnetic particle testing is the best, degree of difficulty, the magnetic particle is the best. Now, time magnetic particle is the best. Only in this situation eddy current testing is the best in the cost point of view. The question comes, which parameter is more dominating? Is the cost more important? Is the time more important? Is the degree of difficulty more important? That is why this method, weighted object method, is required. However, to really make this table, and we will be utilizing the MATLAB code. I think earlier in one of the lecture I mentioned that MATLAB will be available free to all the students who are going to enroll for this class or this course. They can utilize this MATLAB the software for the complete duration of the course from July to the October end. And just to explain from that angle, we have made a MATLAB code, and then we are trying to write this complete table in the MATLAB. How do? We have written something like a parameter matrix. This is a parameter and the matrix. So, PAR MAT parametric matrix. Now, this ER stands for the efficiency ratio, DOD is a degree of difficulty, C is for the cost, OT is operating time. So, here we are looking at only operating point, not a complete point time, and what is the value 1.4, 3.11, 3.3338, 3 has been given in a matrix form. So, this is a 4 by 4 matrix, and then 4 by 5 matrix and has been given, and then when we enter this is kind of matrix is going to come to us, right. So, this is what we can develop in a MATLAB, so that we can we can judge or we can evaluate the importance of which method will be selected and which has a highest ranking. Now, second thing is that how do we decide whether time is more important, cost is more important, or maybe say degree of difficulty is more important. So, what we do, we use a word, a digit logic method. What is a digit logic method? At a time we will be comparing only 2 parameters. Even though we have 4 parameters, at a time we will be comparing only 2 parameters, and then in this situation when we are writing parameters and we have written 4 parameters, we also need to take care that not a single parameter should get an absolute 0 value. That means, if parameter will go out of the line or out of the this algorithm. So, that minimum value to the parameter should be at least 1 on the 10 scale, or maybe say if I do a normalization, then at least a 0.1 kind of value, or maybe lesser, but it should be more than 0. So, this digit logic method, what we do, we make a table, number of parameters, this is the efficiency ratio is a 1 parameter, degree of difficulty another parameter, cost third parameter, time fourth parameter. Now, here the fifth parameter which is not really there, but we are bringing new, that is a dummy parameters, and in all the cases dummy will get absolute 0 value, and all other parameter will get at least relate to the dummy some number, maybe say 1 number compared to the dummy. So, how many columns will be there? We have a number of factors, so 4 in this, and then we multiply number of factor plus 1, that means 5, the 4 into 5 divided by 2, because we are looking at the 2 parameter time. So, the overall 10 columns. So, 1 column, 2 column, 3, 4, 5, 6, 7, 8, 9, 10. Now, what are we going to do in this columns? We say compare efficiency ratio and degree of difficulty, and then judge. Do you require a higher importance to be given to efficiency ratio, or it should be given to degree of difficulty? I select in this case, I say efficiency ratio is more important compared to degree of difficulty. So, I give 1 value to efficiency ratio, degree of difficulty is 0. Now, second efficiency ratio need to be compared with the cost. Is it efficiency ratio more important compared to cost? Yes, it is, should be more important compared to cost. So, I have given 1 number to this. However, it depends on situation, I may reverse also, efficiency is not as important as a cost. So, this is the 1 and 0. Now, coming to the third, the efficiency ratio should be compared with the time also. Is the efficiency ratio more important compared to the time, operating time? No, it is yes, it is important. So, what we say, the efficiency ratio again gets a 1, and of course, compared to the dummy, almost all variable will get a 1, right. So, this is by default efficiency ratio over the dummy, efficiency ratio will get a 1. Now, this is a comparison among 4, right. Now, coming to the degree of difficulty versus cost, I say degree of difficulty may not be as important as a cost. So, I have given 1 parameter to cost. Now, another one, degree of difficulty versus time, we say no, time is more important compared to degree of difficulty. So, the time gets a 1 number, degree of difficulty gets 0 number. Now, dummy, as I mentioned that comparing the dummy, degree of whatever the parameter, it will get a 1 and dummy will get a 0, this is a 1 and 0. Coming to the cost, we say compared to the time, cost has a more importance, that's why the 1 and 0. Compare again dummy, the cost is compared to the dummy, it will get a 1 0, and time will again get a 1 and the dummy will get a 0. Now, we get this kind of number. Now, we need to sum up 1 plus 1 plus 1 plus 1 makes a 4. Now, here degree of difficulty summation is a 1, cost 1 plus 1 plus 1, it comes around 3. Now, time is a 1 plus 1 equal to 2. Now, this summation always will come 10, because we are giving the 10 number as the columns. So, it will be 10. Now, divide if the summation here is and the sum is a 10, divide this to the every number, it means like a 4 divided by 10, naturally that will turn out to be 0.4. Now, 1 divided by 10, it will be 0.1, 3 divided by 10, 0.3, 2 divided by 10, 0.2. So, this is a weighting factor for us. That means, we are going to give maximum weightage to the efficiency, we are going to give a next number weightage to the cost, then comes to the time, and last is a degree of difficulty. So, minimum importance is being given, of course, it is not 0, still we are giving 10% weightage to the degree of difficulty. So, degree of difficulty is also 0.1, the one on the time or operating time 0.2 weightage, cost 0.3 weightage, and the efficiency ratio weightage is a 0.4. And this has been documented also in a MATLAB code. Let us say degree of relative importance the given to the ER, DOD, C and OT is 0.4, 0.1, 0.3, 0.2, and then this is a result as such. Now, we will go to the next step, that how do we establish a utility score for the each parameter. And in this case a factor is a 1 is the efficiency ratio. How do we go ahead? This is a table we got by doing the calculation, and this table was shown on a previous slide, that an ultrasonic we give the efficiency ratio whatever we picked up from literature is a 1.4 for ultrasonic, 1.99 for the magnetic particle testing, 0.88 for acoustic emission, radiography 0.99 and eddy current testing 1.37. Now, we need to normalize it because sometime we will be getting second the unit as a second, sometime we will be getting rupees, and then everything need to be normalized. How do we go ahead with normalization? We go ahead with the utility score. Now, there are number of formulas for utility score, and then what we have selected something like that. What is the objective value? So, in this case an ultrasonic testing objective value will be 1.4. For magnetic particle testing objective value will be 1.99. Acoustic emission objective value will be 0.88. Radiography testing objective value will be 0.99. Eddy current testing objective value will be 1.37. Next one is a minimum value. In this case, what is the minimum value? In this case, minimum value is turning out to be 0.88, right. So, that will come. What is the maximum value? A maximum value is a 1.99 in this case. So, these values are given. Now, we can also remove, I can say instead of 0.1 I can go with a 1, that is a possibility, and then instead of 1.1 I can go ahead with a 1. However, we know that whatever the method which we have selected, in this case we have selected 5 numbers, but there is a possibility of 6 number, 7 number, 10 number. So, still there is a possibility of some technique which will get a lower number than this, and there is a possibility of a number which is more than that. So, that means there is a possibility that some technique which will be included which has a number or efficiency ratio lesser than 0.88, and then there is a possibility that efficiency ratio of some testing is more than 1.99. So, we are just keeping on a scope. So, in future it may change. So, that is why we have multiplied 1.1 with a maximum value and 0.9 with a minimum value. So, that we are leaving some sort of gap. It should not turn out to be 0 or 10, it will be always between 0 and 10. So, this is a method which we will be utilizing. Again this is for the utility score which need to be increased, we need to be maximized. However, if turn out to be the minimization, then I will what I will do, this whatever the calculated score I will be subtracting from a 10. So, what is this score minus the 10 minus this score, that will give minimum value. So, this is the approach we are going to adopt in this case. Now, here there are 5 techniques, and then we are using the word utility score for the ER is a something like whatever this matrix we have made, parametric matrix. 1 the value has been given, objective value in this case, and then it can be iterated for 1 to 5. So, naturally for the first case, as I mentioned, it will pick up this matrix will pick up 1.4, then 1.9, 1.88, and overall score will come, and that overall score when you go ahead with the MATLAB coding, it comes something like this. Utility the score for ultrasonic testing is something like a 4.35. 22, of course, MATLAB gives a 3.4 the 4.3522. However, we are trying to wind up over here with something like a last digit we have removed, or we say of course, instead of removing we can do a rounding off. In this case, slight variation will come, maybe there is a good thing to do round off also this errors, and then we can go ahead with this rounding off, however, only there is a one eddy current, it should be 4.317 in this case. So, that is what we can do, and then we are getting utility score based on this. Now, come to the second one where I say that we want to minimize the time. In this case, degree of difficulty, the factor 2 need to be minimized. That is why the whatever the what we have explained in previous slide has been subtracted from a 10. So, this score minus 10 or maybe say this the subtracted from a 10, it will give a different results to us. Now, in this case what we are saying that ultrasonic testing gets of course the degree of difficulty level which we the tabulated earlier from a literature it was 3.11. Now, when we do this kind of normalization, it gets around 5.6849, and then winding on the maybe the 2 level when we round off is a 5.68, and in this case it is a 9.275. As I mentioned earlier that we require a minimum time, and then magnetic particle testing is the best. If we do not use this kind of formula maybe say 1.1 and 0.9, then we will be getting this value as a 10, because this is the best. However, we are leaving some scope, there is some method or maybe some method which we have not explored may have a 10 value. So, why shall we choose this as a 10? That is why we are trying to slightly reduce it. Acoustic emission otherwise in this case is acoustic emission is a worst, no not worst, radiography is a worst in this case 4.31. Otherwise, if we do not use this kind of formula, then what will happen, the radiography test will get a 0 value. So, we want to avoid that. Now, we should not use a 0, we should not use a 10, that is why this formula has been utilized for that purpose. Now, what is the utility score for ultrasonic? As I mentioned 5.68, magnetic particle testing has the highest utility score 9.275, then acoustic emission 2.339, and worst is a radiography test, that is a 1.503. So, these are the numbers which we get when we solve this kind of algorithm, or maybe MATLAB algorithm, or maybe Excel sheet, whichever is comfortable for you. As I mentioned, the MATLAB complete software will be available for the coding purpose in this course. So, I hope you will be able to utilize the software. Now, coming to the factor 3 cost, we say utility score again need to be, in this case our aim is to minimize the utility score. So, that is why the whole this number or the equation has been subtracted from a 10, and then again our utility score for the cost has been calculated based on this, and then we say that this cost again has come from a tabulated value which was saying that ultrasonic testing per feet cost around 3,338, while magnetic particle is on higher side 7,568, and minimum is a eddy current testing as a 2,000. So, that is why the eddy current should get a maximum value. In this case, if you are able to see that this gets a maximum value 9.782, and compared to the this eddy acoustic emission, in this case the cost is the highest. Again, I am mentioning that this is kind of has been picked up from a literature, but when we do our testing in our lab, we can really come up with the right data. However, if we do a lot of literature, we may get more numbers, and then we can go ahead with the mean value and standard deviation. We can count also those things. Now, here the acoustic emission is a worst 10,000 and is giving utility score as a 1.08 or 1.086. So, this is more or less common. Same thing will happen for the time factor 4 time, and in this case the time again acoustic emission takes a maximum time, but we want to minimize, that is why this whole equation has been subtracted from number 10. And then if we look at 3 ultrasonic testing is also taking 3 minutes, and eddy current is also taking 3 minutes. So, they should have a same value, and this is a 9.405, 9.405 the same value, and acoustic emission is the worst, that is why it is getting 0.99. Magnetic particle testing is the best, that is why it is getting 9.9, again it is not 10, it is a 9.9. Now, if there is a more and more difference, naturally value will be nearer to 0 or nearer to 10, but again it will not be 0 or 10, it will be nearer or maybe closer. So, this is what we have done. We have 4 factors and 5 testing, and then we have done all the thing calculation Now, next one is that how do we go ahead, how do we find overall ranking. For that purpose we need to multiply with the weight. So, in this case ultrasonic in the parameter 1 they got a rating of the 4.353 and weighting factor of the factor 1 is a 0.4. So, that is why that been multiplied. Then the next rating was a 5.68 multiplied by 1.1, third one was a 8.328 multiplied by 3, and the last one is a 9.4 utility score multiplied with 0.2. So, overall score of rating is comes out to be 6.688, it is a out of 10, and then similar way magnetic particles gets a 7.4570. This is another one. Now, acoustic emission somehow gets the lowest value is a 1.0093. Of course, we can go ahead the rounding up to 2 number, whatever the value we are getting from MATLAB we are just coding and we are just using that value. So, now in the radiography is also getting a lower number lesser than 5, it is a 4.775, and the last one is eddy current, that is getting around 7.168, 7.1868. Now, question comes, which technique is the best? And if I go with a numerical value will say that magnetic particle is going to be the best, and then overall MATLAB code also for this purpose has been written. Now, we can say the best suited for the welding testing purpose is a magnetic particle testing, and it has been utilized also in a literature extensively. Wherever there is this kind of welding faults are there, magnetic particle testing is done been extensively. And then if you want overall ranking, magnetic particle has a highest one, then eddy current, then ultrasonic, radiography, and acoustic emission comes the last. Now, when we go ahead, we also need to look at, we have seen the number of faults, it can be surface, maybe near surface, but maybe subsurface also. If there are some surface faults, what will happen? So, we need to look at again and this kind of matrix, the surface related we are getting 3 rank for the magnetic particle. So, for another thing is that it is also for the ferromagnetic materials. Now, if there is aluminum welding, will I be using this method? We need to really think from that angle. Now, second one is the number is coming eddy current. If the material is not conductive, will I be using this technique? So, this is important to rethink. And another thing is that what will happen if there are surface cracks and there are subsurface cracks also, what kind of method shall I choose? Now, here it has been shown that the 3 value for the surface cracks, and then even the subsurface the deep cracks we are able to say the eddy currents are good. So, question comes, do I go ahead with the both together? Shall I use magnetic particle testing as well as eddy current testing? That is what you need to choose. In the based on the numerical method, I can say the magnetic particle is really giving the best result. However, there is some sort of subjectivity, numbers have been picked up from literature, and then either we can go with that. These are the 2 tests, magnetic particle testing and the eddy current testing, giving almost similar kind of result. I will select the both the tests and maybe in the apply, because I am picking up the literature and then the data from literature. So, I will apply both the method for our purpose. After doing a couple of iterations, then I can figure out which method is really very good, what kind of faults are really happening in a welding junction which is happening at our company level, or maybe where we are going to serve that level, or where we are getting training. So, if there are more and more subsurface than the cracks, or maybe say in the faults, naturally I will go with the eddy current base. If there is a more surface crack, I will go with a magnetic particle. However, if it is not a ferromagnetic material, again I will go with eddy current. If it is not conductive and not a ferromagnetic material, I will go ahead with ultrasonic testing. So, this depends on what kind of material we are choosing, what are the limitations. So, this method has been explained from that point of view. So, I am just trying to come to the last slide of the course in this this lecture. We say that in the cracks, if there is a the ranking given, we say that there is a possibility of cracks, there is a possibility of undercut, there is a possibility of the tearing. Tearing is something like a kind of the delamination. You are able to see here that whatever the weld and we are, there is a separation happening, which is the worst, but whatever the welding we have done, it is getting removed. There is another possibility of overlap, or there is a possibility of the porosity. So, in case of the ultrasonic we find yes, 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 yes for all. Coming to the magnetic particle, one is a ferromagnetic material. However, there is another problem. If the tearing underweld happens, that magnetic particle cannot detect, it is a below the surface, or maybe it is not near the surface. Then acoustic emission also, wherever there is a porosity and then overlap, and the signal gets really disturbed a lot, and then we do not get really good results from acoustic emission. So, these are points are also important to keep in mind, and then as I mentioned, eddy current for non-conducting material cannot be used. Or maybe if it is required, then we require a very different kind of material to be painted on the surface. So, overall if we have a good knowledge, and then we can really choose a good technique according to that, or at least if we do not have a good technique available, we have some technique, we can add on also, we can use our own creativity. So, that also will be covered maybe say next lecture, how do we really add on, how do we make our own technique for the good purpose, and how do we really refine that technique using our knowledge, available knowledge and available resources. So, thank you for attending this lecture. We will continue lecture 22 and then with a more advancement in this selection procedure. Thank you.